as we start on topic 5 of chapter 9. We only have one topic left after this in our course. I'm going into a little of a review mode. I recall going to the textbook and doing a lesson on the textbook and then doing the PowerPoint slides and then doing the additional exercises. And this gave me some expertise. And every once in a while, I catch myself in a little error watching it. I don't know if my tongue got in front of my eye tooth and I couldn't see if I was saying the right thing. But anyway, a little review as we start section 5 is something actually I saw on YouTube when I was looking at another professor's stuff. Because, my stuff is there, but other people have stuff there, and, there are other professors and experts and perhaps much smarter than I am about some of these things. But I thought this was rather interesting. So that when we look at this, the log base 10 of 100 equals 2. Well, what does that really refer to? Well, we're saying log, and then what goes down here is our base. And if you want to take notes on this is like a good little summary of a lot of stuff we've been doing in chapter 9. And then over here, actually, this is, we're calling this our answer. And then we said that this equals some exponent. Now, this is the logarithmic form. And we said this was, in a sense, connected to our exponential form, where there is our base. Now, 10 to the what power is going to be the answer? And the answer is 2. So 2 is the exponent. We raise our base to get our answer. And logarithms is just another form of this. Okay. Now, as we go into our learning objectives, and keep in mind there is a natural logarithm, and there's also a common logarithm. Common logarithms are base 10, and we will see in this section that natural logarithms are base e. Base e is a special number that we will talk about shortly in our lesson here. And we will talk about that. We'll talk about changing logarithmic bases. And then we're going to do some graphs. And since I have this online calculator or graphing calculator, that's what we'll use. It gives us some really sharp things. And basically what you do is you don't do a lot of graphing in MATLAB, but you do selecting which graph it is. So you have to sort of match them up. So if you have some basic knowledge, and we spent a lot of time on graphing in earlier lessons, this will be very useful. But what I've decided that I would do here, rather than jump right into the answers, and toward the end of the course, we need a little more time to digest some of these, in some cases, challenging material. I'll use the PowerPoint slides for this. Now, you may recall I do have PowerPoint slide presentations. But here we're using our mini lecture series for this, so I will integrate this for you right here. So these are much of the same things we spoke of. And we're going to take a look at base E and natural logarithms. Well, if you watched our textbook presentation, or if you looked at the textbook, it does show the derivation of letter E. And it comes from using a compound interest formula that eventually you get a value for E. And we say E is irrational. And a quick review of what is a rational number. If we take a fraction like this and convert it to its decimal form, it terminates. 1/2 equals 0.5, and that's it. Or if we have 1/3, which equals 0.3, and the 3's repeat, and the repeating pattern is just 3, these are considered rational numbers. Now, if you get a number like this, where there is no fixed pattern, and it doesn't terminate, it just goes on, we consider that an irrational number. That's why the value for this natural logarithm E is considered irrational. Now, they have this value on your calculator, and usually it's rounded off to 4 decimal places. So here we have 1, 2, 3, 4. We go to the 5th place, it's 8. So we're going to drop these, and we make this 2 a 3. And that's just some background. You won't have to remember this, but you should remember it's a number between 2 and 3 on the number line, and it would be probably right about there. There's where E is. Remember, another irrational number is pi, which is 3.14, which may be a little closer there. Okay, some background. Now, when we are changing logarithmic bases, and they're saying here most calculators can find both common, that is base 10 logarithms, and natural logarithms, base E. To find a logarithm with some other base, we use a conversion formula, and here's what that formula is. Now, this is basically what it is, but there is a shortcut that I will have you write down that as you use the change of base formula, you can use. Now, they wanted to show you the official form of it right here, but we're going to show you this modified form. And they're going to give you an example, something like this. Find this. Well, it's not in base 10 and it's not in base E. It's in base 4. Well, how do you do that? Well, the answer is we're just going to say log of base 10. And on your calculator, you just hit the log key because that is the common log. And you go log base 10 of 24 divided by log base 10 of 4. You put this information in, and keep in mind that you don't have to put base 10 there. You just go log 24, often you have to put a parenthesis, divided by log 4, and you put another parenthesis and hit enter, and that gives you the answer. So in a sense, all you need is the M value, which is 24, and the B value, which is whatever the B value is, that goes in your denominator. And then you've gone to log base 10, log base 10. Now you could have also, interestingly, I find this interesting anyway, that you could have used base E here. So you could have gone natural log this divided by natural log this, and you get the same answer. I don't want to give you too much information because then it gets confusing. So what do you do? Well, again, hopefully you can get this, and we can cross out this and cross out that. We're just going to, because this could be base 10, or base E. Otherwise, you're just in your calculator going to put log of whatever value is in the M position and whatever value is in the B position, and that'll do it. So here is an example. Now notice they're asking you to use the change of base formula to calculate this. There is your M, and then they're putting in the log base 10, and then the 3. Now when you do this, and this is the formula, if you were to do this by itself and then do this by itself, you would get these numbers. But normally your calculator doesn't show that. They're just going to give you the answer, which is this, that you round to 4 decimal places. They're now going to give you a little bit of background on the graphs of exponential and logarithmic functions base E. So they will ask you to graph this. I will show you how to put that into your online graphing calculator, so at home you can do this. In fact, let's do it right now. Now, to build up and to let you get a feel for these, we're going to start with some simple values. Remember, this is function equals E. E is on this calculator. And we put our caret in, and we're raising it to the x power. So what does this look like? Well, believe it or not, it looks very similar to what we've done before. Now, earlier in this chapter, we often graphed this. Y equals 2 to the x power. But remember, now we're substituting y equals e to the x power. And what did we say e was? Well, it was 2.7183 approximate. So when x is 1, remember when x is 0, this is going to be 1, so that goes through 1. Now this line will go through this, where you recall this one was 1 and then it went through 2. So this goes a little closer to your y-axis. Okay? Now, that's just to give you the basic background of this. Now, let's take a look at what will happen if we put in the one they're asking in this graph, that it's going to be y equals e raised to the x power plus 1. Now notice it's not in parentheses. So one of the things I'd like you to think about for a moment is, what do you think is going to happen to the graph we just showed you? Plus 1. Is it going to move it up or down, right or left? And the answer is, it moves it up, because the red was our original line. Now, plus 1, and let me give you some new vocabulary here, or review the old. On the first one we did, the x asymptote was your y-axis. I'm sorry, your x-axis. This x-axis, that's the x asymptote. And what it's done now is it's shifted up 1. So your new x asymptote is 1. This one. This is your new x asymptote. Okay, and it just shifts everything up by a positive 1. Ah, okay. So this is what the PowerPoint is asking. And we get our table, our t-chart. And notice that, again, we are shifting this from what we originally saw up 1 on the y-axis. So where before our x asymptote was the x-axis, or 0, by shifting it up 1, we now move our x asymptote up 1, shifting everything up 1. Okay. One of the things they're going to ask us is, what is the domain then of this? Or even the other equation, what is the range? Well, this is going off to infinity in this direction for our domain. So it's going from negative infinity. Let's just put a comma there, not a parenthesis yet. And eventually it goes over to this direction to positive infinity. Now, how about our range? Well, because of this 1 here, now if the 1 was not there, it would have been 0 that it started at, but now it's been shifted up 1, so it's going to, in a sense, start just beyond 1. Remember, it never reaches your horizontal asymptote here, and it goes to positive infinity up this way now. Okay? Another way you often see this is that it's all real numbers. They kind of thicken that R there. Now they're looking at the inverse of this. This is natural log inverse plus 1. Well, if you recall from our earlier lessons, when we had the inverse, it just reflects across the y-axis, which is the axis of symmetry. That's our y-axis. And what is the equation of the y-axis? Well, it's x equals 0. Remember, when we have an equation in the form of x equals a, it's a vertical line going through the a position, which in this case, x is 0, which is right there at the origin. All right, so a little background. And again, you just want to know that if you have the inverse of this, which is this, the graph is just the reflection of that across the axis of symmetry. Now, keep in mind we have another axis here of the x asymptote, which we described already. Now, here we're going to take a look at this function. And you might say, well, what is this? Well, this is the natural log, but now it's in parentheses. It's not just this and the 1 is out here by itself. You may recall from earlier lessons that in this arrangement it's x minus h, where this one was the h value, and here we're going to shift not up and down, but left and right. So if it appears as a positive, what do you think your h value was? Well, it had to be the opposite sign in order to get a positive one there now. So there's negative h. So negative of a negative 1 gives you a positive 1. So what is that going to do to your graph? Is it going to shift it right to a positive value or left to a negative value? And the answer is left to a negative value. All right, let's just see that because they have it worked out here for us. And since it's the inverse, it's going to shift it downward. And there we have it. So instead of this line being here 0, it shifted it 1. So our new asymptote is going to be a negative 1. So this positive 1 in parentheses here, remember, was a negative 1 because that was negative h. And in order to make it a positive, the negative 1 shifts it to the left. And this is the inverse. So once again, I would strongly advise that you copy this into your notes so that when you see something like it, you know what is going to happen. All right, so back to our lesson. That was a brief, even though it took 22 minutes, there was a lot of information there that hopefully will make this lesson go a little easier now. So, natural logarithms are generally referred to by using the abbreviation LN. And you might say, how is it natural logs with the letters reversed? Because this is actually from the Latin logarithmus naturalis, something like that. Okay. Find each of the following to 4 decimal places. So here we're going to use our change of log formula. And remember, we said it was, we put the 20 right there, and we put the 9 right there. And all we had to do is, when we put that in our calculator, it usually gives us 1 parenthesis. Depending on your calculator, you put another, then you say divided by log, and remember these are base 10 that we're using. So this one will be log, and then 2 divided by log 15. Remember, this is log base 10. We're using the change of log formula, which is just doing it in this shortcut. Okay, now they're asking us to do these as graphs, but we are to use our graphing calculator, and we want to see what goes on here. So for that, we'll use our graphing calculator. So as we look at the first one, we see y equals e to the x power caret x minus 2. So this is not in parentheses. What is this going to do to the graph? Raise it up, raise it down, raise it right, or raise it right. Move it right, move it left. Well, negative 2, again, not in a parenthesis, physically just moves it down. So your x asymptote will be a negative 2. Let's check it out here. Yep, it's shifting that basic curve, so your x asymptote is negative 2. It shifted it down. Okay, so what is your domain? What is your range? Well, this is going from negative infinity, and this goes off this way, to positive infinity. Now your range, this is critical, will start at just above a negative 2. So it'll be parenthesis negative 2, and then on to positive infinity. And this answer is written down below on your answers there. Now, putting in this was a little challenging, but there is your natural log symbol. A parenthesis came up. I put the x in, and then I used a parenthesis that you can't see, but it's in there. And then I'm now going to put in the plus 1. So what do you think this is going to do? First of all, this is the inverse of it. So let's check it out. Now notice it's coming up from our bottom. It's in this inverse position. And we're asked to find, I don't know what this red line is. It came up before. Your y-axis is your vertical asymptote, never quite hits 0. And let's do our range and domain. So here for domain, it's not quite reaching 0 on our x-axis. So it starts after 0 and goes to positive infinity. And now our range starts at negative infinity and eventually will go up to positive infinity here. Let's see if I did that right here. Get the swing of things. Okay. Now in analyzing this one, notice we're putting the negative 2 in a parenthesis with the x. Okay, what's that going to do? Raise it up, raise it down, move it right, move it left. Well, we said now, since this is a negative 2, this is h. So our h value for this to end up being like this had to be a positive. So this is going to shift it right over to 2. Let's check it out. And yes, it's shifting it right. So our vertical asymptote now becomes the 2. So as we do the domain, it will be after 2, 2's not included, and to positive infinity. But our range will go from negative infinity to positive infinity. And this goes up that way, and this goes down. Okay, one more. Okay, this last one was a little tricky because I wasn't quite sure how to put it in there. So I used the change of base formula, and I put y equals log base 10 of what they had there, x minus 2, divided by log base 10 of 4. This is the change of base formula, and then I put it in my graph, and it accepted it, and there we go. So our new asymptote is going to be 2. That was we expected that shifting, and our range and domain are listed below. Well, that'll wrap this up, and it was a little long, but hopefully helpful.